Thanks for coming back and joining us again. So today, this is part 3 with Don Lindsey. And Don, tell us a little bit about what we're going to talk about today.
Today, we're going to talk about the geology of Kentucky. And we'll be right back. Here we go, folks. I want to make sure I thank Miss Kathy because she has put a lot of time in helping me put all this together. Miss Penny the Peacock. What are we doing, Miss Penny?
She's over here hanging out.
Okay. Penny the Peacock, and we are at the Butler County Public Library here in Western Kentucky. All right. This is part 3, Kentucky Geology. If there's any Cub Scouts out there that are looking to get their Earth Rocks patch, first thing you need to do is get you a few pieces of paper and get you a phone or a camera so you can take a picture, because as y'all know, I'm not here to do all the work for you. You got to do some of the work yourself. So here's your first picture. I want you to take a picture of this. And I want you to give me at least 2 or 3 sentences on each subject. Same thing here.
Now, is this to get their badge?
This is for a patch. In Cub Scouts, you get patches.
Okay.
In Scouts, you get badges. And which reminds me, if any of the Scouts that are looking for the geology badge, if I don't do it, I believe Mr. Rick Scott's going to do it probably in the spring. So, I mean, y'all can follow along if you want to. If nothing else, there's a lot of good information here. If there's any 4-H kids, any kids out there interested in geology, if you want to get some information, then send it to me. Miss Kathy's going to give you my name and phone number. And you can send it to me later. All right. In parts 1 and 2, I mentioned thousands and thousands of years when we were talking about the ice ages. Now we're talking about the geology of Kentucky. So I can't get by with just saying thousands and thousands of years. The majority of geologists and scientists believe that the Earth is millions and millions of years old. So I need to kind of go along with their thinking. So in part 1 and part 2, we talked about fact and opinion. My opinion, right? Now we're going to be talking about theory. The geologists and the scientists, they have their theories about how long ago the ice ages were. They believe that the last ice age ended somewhere between 12 and 14,000 years ago. There was at least 20 ice ages. They went on for 100,000 years or more. all right? That's, of course, that's theory. Now, a lot of things that they determine are based on fossil records and things like that, but just remember that is a theory. I did not talk about dinosaurs in parts 1 or part 2. In my opinion, the dinosaurs did not live during the ice ages. They lived millions of years before the ice age. This poster here gives you a rough idea, and I'm going to show you where Kentucky is at. This is about 65, 75 million years ago. Here's Kentucky right here. You might have heard people talk about the inland sea. This is the inland sea. This is why they find a lot of mosasaur fossils in Iowa, Kansas, some of the Midwestern states out there. Now, if we go back another 100 million years, Kentucky was covered, most of Kentucky was covered by a freshwater swamp. That's where our coal comes from. If we go back another 100 million, 200 million years ago, that's where the gas and oil, of course we don't have a lot of gas and oil in Kentucky, that's where it comes from. Gas and oil comes from marine deposits. All right, I've had several people ask me, well, what did we ever have any dinosaurs in Kentucky? The closest thing that we had to a dinosaur in Kentucky was a hadrosaur, which is a duck-billed dinosaur. They have found some of those fossils in Tennessee. So does that mean they never crossed the state line? No, it doesn't. They could have lived here. There could have been thousands of them here, but so far we don't have any fossil record. And I say so far. My hope is that one day, maybe 10, 20, 30 years from now, some of the people that are watching this video right now will be out digging, and you dig up a dinosaur fossil and you say, hey, Mr. Lindsey was wrong. He said there wasn't no dinosaurs in Kentucky. So I want you to prove me wrong. Okay, I want to hold this one up just for a few minutes. This poster here shows a lot of minerals. All right, in real life, if you're out looking in a creek or a river bank, you're not going to find a mineral that looks like this. All these minerals have been cleaned up and polished. So I will show you some examples of what you might find when you're out looking around. I'll show you those in just a minute. There are basically 3 types of rocks. We've got igneous, which is, when you think igneous, think of fire, volcanoes. We've got igneous rocks, so we have a lot of those out west. Sedimentary, that is probably the number 1 rock that we have here in Kentucky. And metamorphic, which is basically a combination of igneous and metamorphic rocks. So I'm going to give you some examples. So none of this stuff here is polished. Here's some coral. This is a piece of sedimentary rock that has some coral in it. Okay. And this is a what I call a plain piece. And all this stuff here is from Butler County and Edmonson County. Now this is a piece of coral. You can, if you look real close, you can see how the coral grows up. Coral is a marine organism. Coral is the skeleton of that marine organism. And this piece is actually mineralized. My friend Melanie gave me this piece. This piece came from Edmonson County. All right, now, when Kentucky was covered by a shallow ocean, we had a lot of shells. If you look real close, these are brachiopods. Brachiopods were very common when we were covered by a shallow sea. Here's some more. And as you can see, there's nothing really special to look at. To a lot of people, it's just a rock with some shells in it. This is two examples of lime rock that came out of my yard. Now, and see, this one looks a little different than this one, but they're both just basic pieces of lime rock. This is how they break up. When you break them up, you can't really see it here, but it is in layers, and a lot of the looks is determined by erosion. Now here's another marine fossil. Now there's an interesting fact about this one, and another thing that I have not been doing is telling stories, because number one, Kathy and I are trying to keep these to 30 minutes. If I started telling stories, these videos would be an hour and a half each. All right, this was like a flower. All right, if you look real close, you can see where there was a stem on here at one time. This was a marine type flower that would have grown in the salt water. This part here would have blossomed, and there would have been a flower in there. Now here's the interesting part. This one here was never used by the Native Americans, but I have seen this same type of fossil in Native American collections. Because look, it's perfect for grinding up corn or whatever, okay? Now, you say, well, how do you know they didn't use this one? If you look right here, this was never wore down. This was found in a field about 80 miles east of here. If a Native American woman was going to use this for grinding corn, the first thing she would have done is turn it upside down and smooth that off, okay? I know they were tough, but why take a chance on cutting your hand on that? All right, here's a piece of conglomerate rock. This is sand, shell, and fossil. And over a period of probably thousands of years, all this got broke up. All the shell particles are very fine. Of course, sand is naturally fine. All the fossils in here are all broken up. They're very small, okay? So, but at one time, all these got mixed together. They got buried deep enough so that there was enough pressure to turn it into stone. So that's why this is called conglomerate rock. All right, this is coal from when we were covered by a freshwater swamp. That's what coal is. It's plants, ferns, trees that got covered up over millions of years, and eventually there was enough pressure on top of them to turn them into stone. All right, this is a piece of petrified wood. You can't really see it real good. If you look real close, you can see the rings right here. All right, this is from out west. It's mineralized. This is a piece of petrified wood. You can see the rings here. Now, and I made a mistake. This is fossilized wood. Petrified wood, to me, is mineralized. This is just fossilized. This is just turned to stone. So that's the difference between Florida and wood from out west. All right. This is an agate. Now, this is probably from Brazil. They're pretty cheap if you buy them at a rock shop. That is probably not the natural color, but in order to get a couple extra dollars for them, they'll put colors in there to make them more attractive, which it is. Okay. Now we have agates in Kentucky, but they're not going to look nothing like that. This is a piece of granite. Now you can't tell how heavy it is. This is heavy. This is igneous from, and this piece came from Canada. I picked this up in Canada. Which reminds me, when you're picking stuff up, I think everybody knows you can't pick up anything in a state park or a national park. Like, I know people have taken pictures of fossilized wood over in the Mammoth Cave. All right, you're not allowed to pick that up. It's okay to take pictures of it, but I wouldn't post, hey, I found this by mile marker 3 on this trail, because somebody else might go back and pick it up. So if you're going to pick stuff up, you need to be on private property and you need to have permission. This piece of, now here again, this is actually a cast of a piece of tree that grew during the coal period, which was the Mississippian period. All right. Now, so this is just fossil wood, but like I say, it's a cast. It's not the actual piece of wood, because there's no rings or anything. The wood rotted away. It left a cavity that got filled in, and whatever filled the cavity in turned to stone. All right, this is a geode. Now, geodes are very interesting rocks and minerals. They form in a void. What happens is, I'll give you an example that what could have happened. This piece right here, when the actual wood rotted away, if some quartz minerals filled this void up, this could have been a giant geode, right? But it didn't. You see all the quartz in this geode? Your geodes have what I call a brain texture. They kind of look like a brain on the outside. But so, see, this one here has been broken in half, and you can see all the quartz crystals inside. All right, now here's a larger piece of quartz rock. Now, a lot of times Native Americans would, if I was a Native American 1,000 years ago, I'd have picked this piece up and I'd have made something out of it. I mean, it's already good enough to be a scraper, but I would have made something out of that. Now, this is an interesting piece. This came out of a cave in Kentucky, and a friend of mine, it was in his rock garden for about 25 years. Someone had given it to him. He didn't know which cave it came from. We didn't try to get no details, but this is called popcorn quartz. Just imagine if you walked into a cave and the whole ceiling was covered in that kind of quartz. It would be beautiful. So I'm hoping this piece came out of and here's your matrix where it was attached to the ceiling at one time. So I'm hoping this came out of a private cave. All right, this is a piece of hematite. It has a lot of iron in it, not enough iron to attract a magnet, but if you look at it real close, you see it's got a little bit of like a rusty color to it. For a long time, if you look at this side, for a long time, I was hoping it was a meteorite, because a meteorite this big would be worth thousands of dollars, because it almost looks melted on this side. But we did some testing and found out that it was hematite. All right, I want you to take a look at this map. This map was made by the Geological Society. Cody Henderson, the surveyor for Butler County, let me borrow this map. I'm going to show you where we're at. Here's Morgantown right here, okay? There's Morgantown. Here's the Green River. I've only lived here a little over 4 years. For a long time, I did not realize how close the river came. This is the cemetery down there by the elementary school. I did not realize how close that the river came to to Morgantown here. Now, all these yellow areas, these are all low areas, all right? This area over in here, if you're over at McDonald's, and if you're in the parking lot of McDonald's and you're looking out back past the feed mill, at least once a year, this area floods. So over a period of 10,000 years or 100,000 years, between all the rains and the floods, this ground, that's why it's so fertile. That's why they plant it every year. It has a lot of new material in it. That's why the ground is so fertile, and that's why the mammoth and the mastodon would be in there feeding, 10, 12,000 years ago. Now let me show you one more thing here, Kathy. If you look, follow my finger right here. If you follow my finger right here, this goes across the southern part of the county. That's called the Hickory Strand School Fault. That's a fault line that goes across Butler County. Now, like I said, I've only lived here 4 years. As far as I know, this is an inactive fault. But unless you study maps like this, and that's what geologists do, is they study maps. You wouldn't have any idea, if you were, let's say, if you were thinking about buying a piece of property along here, I would think twice. I wouldn't want to be right on top of that fault line and buy 20 acres and plan on building a house there. All right, let's hold up for just a minute. All right, Cub Scouts, I'm going to give you a little heads up on New Madrid. I might not have included that in your list. If I didn't, write down New Madrid. In 1811, there was a very, very strong earthquake. There were several earthquakes in that area. This is in the southwestern corner of Kentucky. This would be the northwestern corner of Tennessee and the southeastern corner of Missouri, where they all come together. There were some violent earthquakes. Luckily, there was very few people that lived in that area then. Today, it would be a disaster. For I believe about at least a day, the river ran back up the Mississippi and the Missouri rivers. The water ran back up the Ohio River and the Green River. That's how strong that earthquake was. So if that's not on your list, put it on there, New Madrid. Middlesboro. All right, we write the history books. The Europeans that migrated here 200-300 years ago, we write the history books. In a lot of our history books, it says that Daniel Boone discovered the Cumberland Gap, and that's was one of the easiest ways to get across the mountains and settle into Kentucky. Daniel Boone did a lot of good things, but Daniel Boone discovered a Native American trail that was the Cumberland Gap, and he widened it out so the wagons could get through there. So I want to clear that up a little bit. Now the Cumberland Gap, what's that got to do with geology? Was created by a large meteorite. That's why it's a little more shallow in that area of the mountain, because the meteorite busted that part out. Middlesboro was settled where it is because they found a lot of iron there. Middlesboro is in the middle of a meteorite crater. Now you can't really see it because over the years, thousands of years, it settled back in. So unless you're a geologist, you wouldn't know that there was a meteor crater there. The Corvette Museum is on the list. What's that got to do with geology? You'll find out when you look up the Corvette Museum. If you have to, type in sinkhole, Corvette Museum sinkhole, and you'll see what I'm talking about there. Asphalt, Kentucky. Over in Edmonson County, some of the first roads that were paved in Kentucky were paved from asphalt that came from an area in Edmonson County. Now what had happened was asphalt is an oil and gas mixture. I mentioned that came from a marine environment. Over millions of years, it was formed, but then because of erosion, it was uncovered. If it had never been uncovered, it would have been the biggest oil field in Kentucky. But it got uncovered. Most of the oil washed away, eroded away, leaving a lot of asphalt. So you'll be able to find that. I also have railroad on the list. That's a bonus question. Why don't we have railroads in Butler County? And that's all I'm going to say about that. Let's see. All right, when you look up state fossil and state mineral, you're going to find something interesting about that also. I want you to make sure you make a note of that. Now, some other fossils that come here from Kentucky. We have fern fossils. Here's some ferns here. Now these here actually came from Ohio, which is just north of us. But you can see where the fern pattern is. We have ammonite. We have crinoid stems. All right. A lot of people call that Indian money, and they actually have found some necklaces in some of the Native American graves where they had made necklaces out of crinoids, because the center of a crinoid is open, and so it would be easy to take 10 or 12 of those and make a necklace out of it. Now here's some. This is also from the Pennsylvania period. You see the small little ferns growing up here on this piece of shale. And here we have some smoky quartz. And we have some other examples of some minerals here. Now this piece here, I'm not sure if this piece is from Kentucky or not, because you probably can't see it on the film, but there's a slight trace of copper in there. All right. I was going to get a little more detailed on the Mohs hardness test and specific gravity test, which are both of them are tools to try to figure out what a rock is if you're not quite sure. But when I started putting all this stuff together, I realized I don't want to get too detailed with this, because I don't want somebody's mom calling me up and say, Mr. Lindsey, my son was breaking up rocks on the kitchen table. Can you tell me what that's all about? So I have talked to Jessica. She's one of the Cub Scout leaders, and we will do an in-person meeting probably in September. Hopefully, we'll have a building open. If not, we'll just do it over at Charles Black City Park. But there's a lot of things here that you need to do the hardness test. Now, and you don't have, you can order these off of Amazon. You don't have to, because I've got both of them, the rock specimen kit, the mineral science kit. They have a lot of little samples in there that we can use. You need a magnifying glass. This is more like a laboratory magnifying glass. You need a magnet, okay? You can see here, when I found this, I thought it was a big chunk of hematite. But when I got to cleaning it up and knocking some of the excess off of it, I realized, and I found this in a gravel pit. That's actually a trailer ball off of somebody that somehow ended up in that gravel pit, and I picked it up. Of course, by the time I picked it up, it was pretty much covered, and I cleaned it up and finally figured out, what it was. But we also need we can use a nail for our hardness test. We can use a file. We can use a knife. This is the closest thing we have to a diamond. This is a diamond masonry bit. Got a diamond tipped on it. All right, so if we have something that is really hard, we can use that. We've got some glass. And another reason I didn't want to get too involved with this on a video, we can also use some clear vinegar. So I didn't want y'all going and getting some vinegar out of the kitchen sink and grabbing a hammer out of your dad's garage, and while your mom's out there working in the garden, you're in there breaking up rocks and putting vinegar on. So we will do that in person. Let's talk about specific gravity. Specific gravity is another tool to try to find out and we're basically going to trying to figure out what is a mineral. Okay, I'm going to show you some examples of things that you can't get a specific gravity for. This is a piece of fossilized bone. All right, so this is one mineral, but look here, we have barnacles on here. So if something has two different properties to it, you're not going to get a specific gravity for it. Same thing with this. This is a piece of black quartz. All right, we can't. Well, I say we know. In my opinion, it's black quartz. We can't get a specific gravity on this. Why? Because it still has the matrix on the bottom, which is a limestone type material, so you're not going to get a good reading. This is a piece of pudding stone. If you look real close, you see here, you've got stone, and then you have some other different kinds of stone inside this rock. So this is kind of like a conglomerate where 2 or 3 materials have gotten together and they got reburied. There was enough pressure to turn it back into stone. So that's why you can't do that. Now this here, we got three things going on with this clamshell. All right, the shell itself, part of the shell is still on there. Some of the inside is turning the quartz. And if you look real close, you see all the gray material. All the gray material that you see is silt. That here again, all this got buried together, and there was enough pressure that it turned that silt into stone. So we got three things going on there. So we can't do specific gravity on that. We can't. Now, there is a test for concrete that concrete people use, but for what we're doing, you can't take a piece of concrete block because there's at least 2 or 3 different materials inside this block. And to tell you the truth, we don't really care what the specific gravity of concrete block is anyway. Now, we could do, this is a cast of a clamshell. This is pretty much solid limestone. So we could do a test on that. We have some quartz minerals here. We have some rose quartz, some different colors that we could test. We could test this, and I did test this, but I already forgot the name of it. You see how pretty, it's a very pretty green color. And they polish it up. I forget the name of it. You see how the backside is just plain Jane. When you polish this side, people make necklaces and jewelry out of it. This is a piece of amber. You can't really tell by looking at it. It's very light, very light. This is a piece of volcanic ash. Now, it's been rolling around in a river for 1,000,000 years probably. That's why it's got this smooth shape to it. But this is also very light. This is a piece of schist. All right, we could test that. All right, I'm gonna now this, it looks like a diamond, but when we do our in-person test, we'll test it. I'm gonna say it's glass, okay? Because if that was a diamond, we would be rich. So here's, I'm just gonna tell you how to do the specific gravity test. And if you want more details about specific gravity and mineral tests, when you take chemistry at the high school, Mrs. Jennifer Davis is the chemistry teacher. She can give you all the details. The bottom line is you take and get the air weight of the mineral that you're trying to find the specific gravity for, all right? You write down that number. Then you take and you suspend this in distilled water, and it's going to give you another measurement. And I got to admit, I bet you I watched at least 5 videos on YouTube on how to do this, and it's when you finally figure it out, it's not that hard to do, but it's just kind of hard to understand. So what we do is you take the measurement that you get in the suspended water, and you divide that into the measurement that we got in the air, and you get a number, right? And I have a chart. You take that number and you look on that chart, and it tells you what family that specimen is from. All right. Now it might put you in a general area, like if you know, this one wouldn't be, but well, like this one here. It would tell us if we did this that this is in the quartz family. All right. So then, like I say, this is a test. This is a tool. It will, of doing this, doing hardness test, we can pretty much figure out what kind of minerals that we have. And when we do our in-person, y'all are the Cub Scouts or whoever comes, you're welcome to bring some stuff from your yard or your creek, and we'll do some tests on it. And I believe that is all I got. Thank you very much.